Okay. Hey everyone, I'm Stephen. I'm going to talk to you today about the wonders of NUMA. So this is a 10-minute presentation. I'm going to go through a lot of information very fast. If anyone has questions, feel free to ambush me afterwards and I'll hopefully be able to answer some of them. So quick introduction. What is NUMA? The initialism means like non-uniform memory architecture. In practice, what that means is you have system memory and the amount of CPUs and the amount of memory you have in the system has grown so large that it no longer makes sense for all memory in your system to be accessible at the same levels of latency from different CPUs as other ones. So this becomes, you see this more with like multi-socket systems and high core count systems. You're generally not going to have to worry about this on like a desktop class system. From a graphical perspective, it means if you have two different NUMA nodes, which can be sockets, they don't necessarily have to be sockets though, you can, your memory access times can take longer depending on which node this memory is affine to. So if you have to cross across the interconnect, that will take longer than if the memory is local to your particular node. When you're talking about something like Intel's architecture, that's usually implemented via like some form of like a mesh interconnect. So previously that would have been QPI, and before that it would have been the front side bus. I can't actually remember what the new coolness is, some other interconnect. And again, graphically, anything that's any memory accesses that are going directly from your node out to the memory are pretty good. Anything that has to cross across this interconnect is going to suffer a performance penalty. And this also applies to anything that uses memory, which is also PCI devices. So if your PCI devices use like DMA or anything, they're going to have a NUMA Affinity issue. And you can model this stuff with the likes of like the LS Topo tool, which is what this output is. From OpenStack's perspective, there's a couple of interesting features. This is almost all libvirt driver specific. Some of it applies to the Hyper-V driver. I'm not sure about Zen, and I'm pretty sure that none of the other ones do NUMA at the moment. I'm going to go through each four of these in turn. The first of them is NUMA guest topology, so NUMA from the perspective of where your guest vCPUs get placed on the host. So if we create a sample flavor, we might want to divide that, the vCPUs that it's using into like multiple distinct NUMA nodes on the host. So you can do that using this. Anyone that's worked in like the NFV space will probably be fairly familiar with this. That means that your vCPUs are split evenly into two NUMA node allocations. They'll get placed, so the 3 CPUs will get placed on one host NUMA node and the other 3 will go on another host NUMA node. They can't share the same host NUMA node, and a guest NUMA node won't be split because there'd be performance penalties to that. You can also do funky stuff like saying which of you can do like uneven allocations. So I want 4 of my vCPUs to go on one NUMA node, 2 on the other, and so forth. An important thing to note here is that all these numbers I'm talking about are guest NUMA nodes and guest vCPUs, not host NUMA nodes, not host CPUs. There's no way to say I want my guest to use host cores XYZ. Nova doesn't expose that, and it never will, as far as we're concerned at this point in time.
Does it also mean that even though the guest NUMA node sees this NUMA structure, they could all be on the same NUMA?
No. There's no reason that couldn't be the case, but at the moment, they're always split onto different ones. Yeah. Another thing that you'll see is if you're turning on CPU pinning. So when it comes to CPU pinning, we don't split guest NUMA nodes across host NUMA nodes. So if I have a host architecture like this, and I want to boot this previous instance which had 4 vCPUs, it'll make sure that those vCPU processes all land onto the same host NUMA node. It won't allow you to split them. Now, if you have something like one of those cores has been disabled, it's been marked as not usable by Nova, or there's like another instance already there, then Nova will kick things on to the other host NUMA node, and it'll, again, make sure that everything stays within there. Yeah, you can change that by using the previous NUMA nodes feature, but so as an example of that, if I decided to boost the vCPU count to 6, if we remember we only had 4 host CPUs, in that case you'd bring in this NUMA nodes feature that I was talking about previously, and now suddenly your thing will get fitted across the way you expect it to. PCI NUMA Affinity, if your PCI devices use system memory in any way, which would be most things NICs, vGPU, or GPUs, all that stuff, they're going to have NUMA Affinity, which means, and they're going to be tied to a particular NUMA node. You get some funky NICs that actually are split between, I think Mellanox makes some that can be associated with multiple NUMA nodes, but we're not going to go into that here. So that means if you go and you boot an instance and it's affined with a particular host NUMA node, again, Nova will make sure that your instance gets booted on the same thing. If that's not possible, we have a feature which, yeah, keep going. If that's not possible, we have a NUMA policy feature which tells Nova that you would like NUMA Affinity for your PCI devices if possible, but I care more about the utilization of my resources, and if I can't get NUMA Affinity, I'm willing to take the performance penalty, which can be quite high in some use cases, like up to 50%. 30 is usually more common. But if performance isn't the most critical thing, then that's usually an acceptable trade-off.
Is that preferred setting a default, or is it something?
No, legacy is the default. So legacy will, if your PCI device doesn't expose NUMA Affinity, it'll ignore it. If it does, it'll use it. And practically all PCI devices will, unless they've got dodgy firmware or they don't use DMA, like some of Intel's built-in FPGAs don't have a NUMA Affinity. The last one of these is coming soon. vGPU support, which was added in the last cycle. We currently don't expose NUMA Affinity for that. So if you have a vGPU on one NUMA node, it could be, your instance could be scheduled to another one. You're just going to have to deal with the performance impact of that. Also, if you're using something like vSwitch through Neutron, you don't get the affinity for that at the moment. We're working on fixing that this cycle. So some common questions that I see fielded at me, because I typically get stuck on these bugs in Red Hat. Can I choose what host NUMA node my guest runs on? Absolutely not. We don't support this by design because it's distinctly uncloudy. Generally, if you want, there's usually an underlying reason that this request comes in. It's like my vSwitch affinity isn't being done correctly or something. The Nova scheduler, if that's not doing the work for you, it should be enhanced to do that work for you. You shouldn't have to make these decisions for it. Reasons you might want a multi-node guest, in some cases it can be by necessity. So for example, I have 2 PCI devices, they're on different host NUMA nodes. I need my instance to spread across those host NUMA nodes so it can get affinity to both. Also, if I want to boot an instance with 36 cores and each host core there's only 16 cores on each host, then you're going to have to split things up. It's kind of a leaky abstraction, but it's just how we do things. Can a guest NUMA node share the same host NUMA node? Not at the moment. We might change this in the future. This is just how it is. And some misconceptions then. Host NUMA node selection, again, can't choose this. I just really want to reinforce that. A NUMA node doesn't necessarily have to be a socket. Intel has this crazy cluster on die architecture where they actually divide the core, or the physical CPU is divided into multiple packages. So that means you'd have a dual socket system which actually has 4 NUMA nodes, or it could have even 8 NUMA nodes. Similarly, if you request that your host be divided up against multiple host NUMA nodes, you can still change the actual topology that the guest will see inside the VM using something like CPU sockets and so forth. So you could have two split across two host NUMA nodes, and in the guest it would look like 4 sockets. And then finally, CPU pinning isn't necessarily a requirement when it comes to this NUMA stuff. Things like PCI devices and that will affect your NUMA-ness of the instance. So that's a very quick, as much as I could squeeze in 10 minutes. If anyone has any questions, I'd say I have like 30 seconds. And if not, I can catch people here. We're good? Thank you, guys.